Hello and welcome to the recording for AMI Practical 9, Tutorial 9. So this week we're going over some concept learning, and specifically we're looking at the version space candidate elimination method. Also just a real quick introduction to what the whole point of this idea is. This is mainly for use with binary classification is the idea. And the idea that candidate elimination goes around is the idea of trying to find a hypothesis or a version space, which is basically a bunch of hypotheses that is the actual hypothesis for a situation, but not necessarily always being able to directly reach there. And so it's the kind of idea where, say, you have you can view this as basically as like a hypothesis space, or you say like a problem space, that has two dimensions to it. It's basically just a box. That's all you really need to think of this as. And you've basically start off with the idea of you have your most general set, which is basically everything in the entire universe, and you have your most specific set, which is representing literally nothing is the idea. That's kind of G0 and S0 for your hypotheses. And then say, if you introduce an example which is not allowed, so this is in a binary classification, we have yes and no, this is a no, well then our general one is going to have to basically shrink from what it was before. Whoop, undo that. It's going to have to shrink from what we had before. And that'll basically be our next version of the hypothesis for our general one. And then if we have something which is positive, we need to increase the size of or basically make it more general to allow that our specific one will basically have to include that tick in its space, is the idea. So basically one keeps shrinking with negative examples and one keeps growing with positive examples. And then somewhere basically in between those two is where the true hypothesis or hypotheses will basically lie. That's the version space kind of idea behind things. But yeah, it's a little bit of an abstract example, but it's the general idea is basically you've got two things shrinking towards each other, and somewhere in between in the infinite possibilities in there is what we're actually trying to find and look for, or at least define in this case. But so get rid of that for the time being. Now let's just jump over to the practical content. So for this, I'm going to try doing basically specific at the top, general at the bottom, and trying to move them towards each other to kind of show that off. But by no means you do need to have them like that. You can have them side by side, two separate columns. You can do this in any way you really want. But we're going to be going with the question 1 first, which is going over just positive examples and negative examples with red, 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 white, 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 that one. Also, one thing which you technically can do is you can do an S0 basically for your very, very initial state. You don't particularly need to, but if you do want to technically know, basically the initial state of your specific hypothesis is each element here is literally the value of basically null or none, empty set kind of idea. So with this as well, so basically we have, if we're looking at this, we have our positive, negative examples there, which is listed on the left, sorry. And on the right we have 6 attributes. That's why I've gone through and put basically 6 elements in our little set here. We're also going to go down and make G0 our initial starting point. And basically what the idea here is we're making this as general as possible. Question marks basically represent here the ability to accept any value. Any value that basically falls into this we'll just accept. So if we had for our elements pink, purple, white, 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 red, 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 that's way more than the actual elements, but this will accept that, whereas this will reject everything currently. So the top one literally accepts nothing, the bottom one accepts everything. And then going through our positive, negative examples, we'll start to shrink those boundaries is the idea. So I'll go through, we have our example 1, which I'll just do from both ends, and this is a positive example. And one thing which I have brought up here on the right is the actual pseudocode for this. So one thing to basically remember is, I highly recommend probably, first off when you're doing this, just have the pseudocode next to you. It can be really helpful, because it can be a little bit confusing at times as well, which way around you're supposed to do things. On positive examples, this is basically this section of pseudocode up the top. Remove from G any hypothesis that is inconsistent with EP, which is the example that's positive. Now, our example accepts everything, so it is most certainly not inconsistent. Basically, in this case, we're treating consistency as, does it accept it? Does it match this rule? And this rule says allow anything and everything into each element, so of course that works. This one, though, says allow nothing, so that one doesn't work. This is also the stage where you could actually jump in. It's just start at part 1 rather than doing this initial G0, S0 part. But this is just the more technical way, just in case you have a negative example coming first, which is highly unlikely we're going to give you guys that. But yeah, so now it's for each hypothesis in S that is inconsistent with EP, blah, 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 blah. Again, for part 1, all this really is basically initialize it to the very first example you have. So our first example we have is red, 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 white, white, white. Now that's really what we're going to be starting off with here. And our G1 starting off as question mark, question mark, question mark, question mark, question mark. Drawing question marks on this is very difficult. Forgive me if they start getting really wonky. But yes, this is the real main starting point that we normally start off with. So basically our specific is specific to our most basic example. And we've got our general still being completely general. So that's really our first case. Then let's move on to our second case. Now we have another positive example here. So with this, we're really going to be again looking mainly at our specific, but first and foremost, remove anything from G that is inconsistent with it. Again, we're accepting everything, so I'll mark that as the same. So this one going ahead is still accepting everything. That's good. This one going ahead, well, let's have a look what we've got. So our example is red, 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 white, gray, white. So red, 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 white, gray, white. Now this doesn't accept it here. This is trying to match just red, 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 white, 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 but we have a gray in that second last position, and this is a positive example. This means that we have to be accepting it. So this one is failing to do so. So I'll just do a little red arrow there saying it's failing. So we have to make this one more general is the idea. So our S2 is going to be red, red, red. Now basically we always want to introduce minimal changes. So the only thing we're going to change here is just what was our issue. So white, we'll introduce one question mark there, white. And so because we only have one inconsistent value, we can just change that single one. If there were multiple inconsistent values, we'd have to start generating multiple of those because we want to introduce a minimal change, and if there's two issues, it could be one or the other. So we'd have to generate two of them. But we'll see that kind of popping up in a little bit. But let's jump over to the next one. So let's go up to number 3. And that is another positive example. So again, we're still looking at this part of the pseudocode. So with this, again, our G is still accepting literally everything. So remove from G any hypotheses that are inconsistent. Well, this will be consistent with everything. So it is most certainly still saying the same. But with our S, does this still match up? So we have red, blue, red, white, white, white is the current example. So if we look at this, we've got red, blue, well that's inconsistent, red, white, white, white. Everything else matches though. So we've got white, question mark, white. Basically again, the question mark will accept anything and everything. So it's totally fine to have a white, white, white again. Even though it was what we originally had, it's still going to be accepted. So we're going to make a new specific hypothesis. And again, we only have one difference currently, which is really nice. So we only have one basically new option, which will be red, question mark, red, W, question mark, W. Cool. And so as you can see here, there's a little bit more to this, but in the case of where it's pretty simple like this is all you really need to do. Now let's go up to our fourth example. And this one is a negative. This one we're going to start to do something a little bit different. And this time we're looking at this part of the pseudocode. In this case, remove from S any hypothesis inconsistent with En. So now if we actually had we only have one specific hypothesis. So if this doesn't match, we're going to be able to find a hypothesis that will match up with this. So red, pink, pink. Red, pink, pink. Sweet. It doesn't match up on this one, so it is entirely inconsistent. Again, the way you work with this, it has to match the entire rule, is the idea. Otherwise, especially as soon as one thing goes wrong, it doesn't match. And because this is a negative, we don't want to be matching it to our specific here, or we don't want to match any of them. And that's our real issue. It's a negative example, and our general example is currently matching literally everything. So we have to now shrink our general example. So for each hypothesis in G that is not consistent with that, remove it, so basically don't keep it, and add to G all minimal specializations of H, H being the hypothesis we're currently working with, such that H is consistent with En, so let's make sure that it's consistent, and some member of S is more specific. So the idea is don't become more specific than that. The main point here is minimal specializations. Also, when you do this, if you have multiple ones left over and some are more general than others, remove from G any hypothesis that is more general than another hypothesis. So you want to be keeping the most specific here is the idea. And actually on the other one, it's going to be the opposite. You're going to be keeping the most general. Anyway, let's jump into this before that gets too confusing. Main idea here is basically we're going to start introducing some of our specializations from up here, but we want to do it in a minimal way. So our G4, we're going to start having multiple of them. So we'll do G4.1. So we don't want to match this. So what are some minimal specializations we can introduce? So a negative example here is red, pink, 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 blue, blue. So we want to basically introduce a minimal specialization from our special hypothesis into our general hypothesis, which will make sure that it doesn't match this case, because this is our negative case. So what can we do with this? So if we introduce basically the R, and so we just have R question mark, question mark, question mark, well, that will still match with this. So we can't do that. That won't work out. Because if we have R question mark, question mark, question mark for all the other ones, that matches this. So that's not going to be the one to do it. So what else do we have? So we have so what we do is we have the second R in this case does not match up with this P here. So we could introduce that. Same with the W does not match up here. So if we introduce that, it would not match this case. Same with the final W there. So those are the three ones that we can introduce from our specialized hypothesis that do not match this case. So the first R there, if we put that in, wouldn't work because it would still match this negative case, which we most certainly do not want. So we'll have to do the other ones. So we have the options of question mark, R, question mark, question mark, question mark. And again, the reason why we basically make multiple of these is because we want to introduce the minimal changes. So we only want to change one thing, but there are multiple different versions of one thing we could change, so we have to go through and do each of those to properly represent all the possibilities. We can't just arbitrarily pick one. So third position R, then W in the fourth position, and finally G4.3, question mark, question mark, question mark, question mark, question mark, W. The word question mark is going to lose all meaning to me eventually by the end of this prac. Alright, so that is, so going to the next one did not work, so we had to specialize. But the thing which is nice for this one, oh sorry, I'll do my little there as well. That one we had to specialize there. I was going to generalize on that one. But that didn't match it, so that's okay. So that one's fine to keep the same. So that now doesn't match the negative case anymore, and is now only one more specialized in each of those cases. So that's currently what we're going to be working with. So that's what we do in that case. And remove from G for any hypotheses that are more general than another. Well, these are all just one, and we have nothing that is more general, so that's totally fine. So let's move on to the next example, which is another positive example. So we're going to be looking back at this section. So with this one, does our previous specific match up? We have red, 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 white, white, yellow. Okay. So this one does not match up, unfortunately. So with this, what we're going to have to go do is again introduce a generalization to basically, again, minimally. So we go through, and the only one that was inconsistent was this last one, so we'll also generalize that last one there. And so with this, now the other important bit is what on our general still matches up. So red here, that one still worked. The white in that position also still worked. The white in the last position did not. And so if you look at this one, it's removed from G any hypothesis that is inconsistent with the AP. That one is removed. So we've only got two remaining ones. The idea here. We keep both of those, but we do not keep that third one. Cool, so let's jump to our next one, number 6. Once again, we have a negative example. So let's jump there. So does our specifics still match up? Again, we only have one, so if this doesn't work, we don't have an answer. Green, green, cool. That first green doesn't match with our first red, so therefore this does not match, which is what we want. We don't want to be matching our negative examples. So this one is still totally fine. But, so, for this one, do some of these match? So what do we have? We have green, green, black. So green, green, black. This one doesn't match, so that's actually fine. Because again, we don't want to be matching now. Normally we want to check if it matches, but this time we don't want to match. And so this one, we have green, green, black, pink. This one doesn't match either. Well, that's awesome. So that means that our general hypotheses are actually still okay. We don't need to adjust those. They are not they are not being consistent with these values. So you see, which is negative for each hypothesis G that is not consistent with En. Well, in this case, we want to be this is consistent because it's correctly negating it is the idea. Remove. So in this case, everything's all good. So there we go. And so our last example coming up, number 7, is another positive. So in this one again, remove from G any hypotheses that are inconsistent with EP. So in this case we have red, red, yellow, red. So that one still matches. And we have red, yellow, red. Those match everything. White, white, yellow. That still matches. So our general hypotheses here are still all good. And so this one, our final one, we have red, yellow, red, white, white, yellow. Well, that one also matches up. That one is also fine. Those last two examples there, we didn't have any issues with. So with this, that means that our final hypotheses for our general, and our final one for our specific, is we have, let's do specific, let's draw them out fully. So we have, sorry, we have multiple of the general ones. We have question mark, red, question mark, question mark, question mark. And we also have G7.2, question mark, question mark, question mark, W, question mark, question mark. So I'm sorry if there's an error in here somewhere. There's a lot of different values I'm having to write out. Red, question mark, red, white, question mark, question mark. Okay. So This is basically, as we showed before, this is like our tight bound, this is our looser bound. So somewhere in here is going to be our final is our version space, and we can go through and generate just some hypotheses to see what that could be. So the idea with this is we can go through and we can say, okay, so this is our specific, this is our general bound. So what can we actually have here? And one way to show this off is basically, it's especially nice when we have this kind of example, because it's easier to do all the possibilities here, because we have specialization of 3 there, specialization of 1. So we'll go through in the middle here and generate all specialization values of 2. If there was a difference between this, basically you could have, if that was 4, you would have 3 and 2. If there's no gap between it, basically it's going to be the specifics or the generals is the idea. And if they meet up into one exact hypothesis, then you're fine. Again, the only other issue we have is when we have, if this became more general than this one, that's when it starts to completely fall apart. Or if we remove all options from either one of these is when everything also falls apart. But for the time being, this is all good. And some of the basically final version space we can have as well is we could also have, so R, and so let's pick that one and introduce one from here. So there are a few different ways of viewing this. You can pick these and pick one from there, or pick this and pick one from there, or say I'll start with R and introduce those two. Basically all the different options we have are R and R. We'll have R and the white. I'll comma between those. And we'll also have the second R and the white. I believe that should be all of them. Yes. So this is basically our final version spaces. Those are our specific and general bound, and in between them, those are also the hypotheses that could also potentially be the true hypothesis. It's that kind of idea. That's our kind of, again, bounded version space. So cool. That is part 1. And so with that, let's quickly jump through the second example here. So, and let's quickly jump into part 2. So with this, we're going to have only 5 examples this time, and we're going over, I believe this is if someone has an allergic reaction to the food. Now, one part of this, which is very strange, is that one of the attributes is if they actually had a reaction or not, which is also what the class label is. So 100%, one of the hypotheses that will definitely be part of this is, did you have a reaction? If yes, you had a reaction. So that's definitely not probably the best attribute to have in there, but it's part of it. So we'll work with just what we're given. So again, this one, let's just probably just jump straight into S1 and G1, because there's no real point in doing the S0. That part's just extra confusing for no reason. And so we've got 1 and 1. And we're starting off with a positive example. So basically, our specific must start as specific as possible, which is going to be the restaurant. We have the meal, day, cost, and reaction as well. And so we have, just making sure I can still represent these easily. So I'll do, oh, so I'm here. I have a restaurant. Oh no, I hope my restaurant isn't the dodgy one. We'll do SM for Sam. Do B for breakfast. Do F for Friday. We'll do C for cheap. And we'll do Y for yes. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Perfect. Awesome. So, and our general will start off as general as possible. There we go. Awesome. So that is just basically step 1. It's just on a first positive example, you just go, cool, sweet, 100%, specific as possible, general as possible. And jump on to part 2. So with this, we've got straight up a negative example. So, do we stop here, write dead in our tracks, or is this okay? So this negative example, does it match up to this first one? No, it does not. Then we're good. Because again, if a negative, basically will, or if in any case, if it removes everything, then, well, you can't do much with that. But so this is okay. Our negative example does not match up, because first of all, it's a Lobdell's, and Sam's is part of the matching part of this rule here. So as soon as our first one doesn't match, the entire thing doesn't match, so easy. And we don't want to be matching this negative example. So yeah, to be consistent in this case, we must not match it. But our G is not consistent because our G matches everything. So in this case, we're going to have to introduce a lot of different stuff. So what here, basically, so again, we've got Lobdell's, then we've got lunch, we've got Friday, we've got expensive, and we've got no. So the only stuff here, so what we can introduce is, again, basically we want to introduce one thing at a time here. And the only thing that matches up here is Friday. So if we introduce Friday, that's not going to be something which will work, so we'll still match it. So we can introduce everything but that Friday. So our G2.1 will be, what if it has to be Sam's? Is the idea. Our G2.2 will be, maybe it has to be breakfast. G2.3 will not have to be, maybe it has to be Friday, because that would still match this negative example. Maybe the food has to be expensive. Or maybe it's the fact that you didn't have a reaction is the specific thing which, nope, I'm introducing the wrong part. Maybe it's the fact that you had to have had a reaction for that to happen. So, again, a little bit weird that that's one of our attributes, but that's one of the things we can introduce to make sure we don't match that example. And so now, that should be everything. Again, that one inconsistent, so that was bad. So, that should be everything now, and none of those should match that negative example we came up with, and they're each minimal specializations. So we're doing well. Let's go up to number 3, to which we have a positive example. So this positive example is Sam's lunch Saturday cheap, yes. So first and foremost, with this positive, remove from G any hypothesis that is inconsistent with EP. So it's still at Sam's. So, looks like my restaurant maybe is the issue here. It's now lunch, so it does not have to be breakfast. So that one no longer matches. So that one is removed. Oops, sorry. Oh, also incredibly sorry. I wrote down E here. That should be cheap. Maybe it has to be cheap to have the reaction. Very, very sorry. Hopefully I didn't confuse anyone with that. And if you spotted that before I did, very well done. 10 points to your Harry Potter house. And so with this one, this one we've also got, so cheap, it's still cheap, so that one's still okay. And yes, you are still having the reaction, so that one still matches. So we keep all the other ones, but we don't keep that one. But so, does our specific still match? So Sam's, breakfast, okay, nope. It's now lunch, so it's positive, so we have to make this one now accept that. It's also not Friday anymore. It's still cheap, and yes, they are still having a reaction. So now there are 2 changes that we could potentially make. So breakfast and Friday are the ones that are inconsistent here, and we have to make them consistent. So in this case, we're looking at our example over here. we have Sam's breakfast Friday cheap yes, and now we've got Sam's lunch Saturday cheap yes. So now I've got two things that don't match. So we're gonna have to generalize this instead of just by one, but just by two. Because to basically make a single one that matches this, if we introduce just one change per one, we would have two that didn't match. So we'd have to basically double specialize again. But there are still cases where you can end up with multiple of these. Cool. So with this case, we're going to need to generalize both breakfast and Friday to have it match at all. But yeah, so in this case, we have to generalize both of those so that now we actually do match, because that's what we're just trying to do. If we just introduce one per one, that's where we'd actually end up with two that don't match, and would have to then generalize both of those to actually make it work, and then we'd have the same one. So it was not consistent, but now we have fixed that. Cool. So in this case, so what we're going to be working with here now is going to 4. And so with this, we're now going to be working with another negative example. So with this one, what do we have? So we have now Sarah's breakfast Sunday cheap no. So what is inconsistent now? So again, we want to make sure that everything here is not matching is the idea. So let's remove anything from S that is inconsistent with E, or this example we have. Sarah's, cool, this does not match. So perfect, done. This is still consistent. It does not match. But, so let's have a look at our general ones. So Sarah's does not match Sam's, so that's fine. That one gets to stay. We've still got our G2.3, which is that it's cheap food. And this one, Sarah's breakfast Sunday cheap, is still cheap. So that one is matching, whereas this is a negative example. That is not what we want. So in this case, we're on the negative example, so we're going to be introducing specializations to this one. So for the time being, I'll just mark it for specialization, because that one did not work. Again, not on the positive example, we remove them, but on the negative example, on the general case, is when we specialize them. And one at the end does not match, so that one's also fine. So that would be effectively carried over into the next one. But so with this, specializing from here, we're going to be, we've got C, so what can we specialize? So to bring this back up, so we've got Sam's and yes. So the two ones we could have here are G4, and I'll just write these down currently as G4.1. So it could be Sam's, question mark, cheap, question mark. Or it could be G4.2, question mark, cheap, yes. Those could be the two ones we have there. Now, so we've generated two more, and we still have our ones from before, because they were still consistent, but now remove from G any hypothesis that is more general than another hypothesis in G. So these have basically a specification of 2. Each of these have specifications of 1. So they are more general. So we don't actually keep them. We do remove them. Because they are more general than those two. So those are just our two final ones there. Cool. And then up next, we have a final and last example. Again, if people just remember, so it's just dealing with that rule there. Final example, another negative. We have Sam's breakfast Sunday expensive no. So Sam's matches, breakfast matches, Sunday matches, expensive doesn't match. Awesome. So we get to keep that one. So S5, I'll just write it up This is the final one. Sam's, question mark, cheap. Yes. Still consistent because it's not matching this negative. And our one here, we have Sam's, question mark, so we have Sam's, breakfast, Sunday, expensive, so that one doesn't match. That one gets to stay alive. And the last one, again, cheap is not, it's expensive, and we have cheap, so it is also not matching, so it's also fine. So those are our last ones. So I'll write them up nicer up here. G5.1, we have Sam's, question mark, cheap, question mark, and G5.2, question mark, cheap. Yes. Those are our two final ones there. And so in this case, we have a specification of 3 and a specification of 2. So our bounds are basically almost touching. They haven't exactly converged. But so in this case, we don't really have anywhere in between to generate any new hypotheses. So all we have for our version space are just those two boundaries. So you don't need to worry about going through and producing any other intermediary ones is the idea. Basically all the options are currently here. So yeah, that is basically the part 2 of the prac. And so that is basically everything. Hey, thank you for watching, and hopefully I will see everyone in the pracs coming up this week, or for those who are in my pracs. Anyway, I'll see everyone there.